hopefully are aware, this is the last lecture in this course. So I'm just going to tell you what's on the exam. Tell you what topics are covered on the exam, not tell you what's on the exam. And then I'm just going to go over an old exam. So this is one of the exams that is not currently on OnQ. If I remember, I'll put it up, though, later on so that you can have a record of it. Also, I'll post the recording of the video. So the exam covers only the C part of the course, right? It does not cover any bash whatsoever. So in the C part of the course, because you've already taken 124, the basic C language is essentially the same as the basic Java language, right? So there really isn't anything there for you to know, anything new there for you to know. So I think there's only 5 things that are new in this course, right? There is the fact that arrays are weird in C compared to Java, right? There is pointers to functions, dynamic memory management, and file input and output, right? And so those are the 5 things you kind of want to focus on if you are when you're studying for the course. You get a summary sheet on the exam, so you don't have to memorize the standard library functions, right? You don't need to memorize what order the parameters go in or what arguments you pass them to. You don't need to memorize their names, right? I guess obviously you have to know roughly what they do or that the functions exist, right? Let me just show you the reference sheet that I gave them for this particular exam. The reference sheets change slightly from year to year depending on what exactly is on the exam, right? So here's an example of a reference sheet, right? So how to make an array, how to make a pointer. This is hilarious. So the reference sheet tells you how to make a pointer to something, and often there will be a question that says, show how to make a pointer to something, and like half the class will get it wrong. Not half, that's an exaggeration. But you know, not everybody gets it right. There are your memory allocation functions, right? Printf, here are the normal conversions, right? The common conversions. How to read from a string or a file is here, right? Some possibly useful string functions, right? Some years there's 2 reference sheets. Usually it's just 1, right? So you don't have to memorize any of the. You don't have to memorize exactly how the standard library functions work. Right. So this says the exam's 2 hours long. I think this year it's 3 hours long, but it's the same. The exam has the same number of questions. It's not any longer, right? So so the exam should be easily doable in the amount of time that you have. Yes. I mean, you can. So those are useful to know, right? To how to do them, how to use them. So memmove and memcopy. But if you don't remember how to use them, or if you don't remember that they exist, or if you're a little shaky on pointers, right, you can always implement those yourself, right? You just copy part of an array into another array. So yes, they could be there. Even if you forget that they're there, you don't need them to answer the exam. Right? All right, so the exam, what does it look like? So this one's got 5 questions on it. It's worth 60 marks. You're right. Yours might be 6 questions worth 65 marks or something like that, right? It's roughly the same. Okay, so typically there's a bunch of short answer questions, right? By short answer, I mean very short, right? So when you look at my answers in red, you'll see that they're extremely short, right? You don't have to write out full sentences. It's a waste of time to do so, right? I mean, let's just look at the questions in this particular exam. So the short answer questions cover basically everything in the course, right? There's a question that tries to test whether or not you've got some basic knowledge of most of the topics that were covered in the course. Right? So all the way back to when we first wrote our first C program that got command line arguments, right? This one's asking you, if you run the program like this, right, what is the value of that? Right? And so remember, in a C program, argc is always equal to the number of command line arguments plus 1. Right? Because one of the first value that's passed in this array is the name of the program. Right? More precisely, it's how the program was invoked from the command line. So anyway, there's 3 command line arguments here, so the total number is 4 for argc, right? Second question wants you to get the length of the first command line argument that was passed to the function. Right? So here you need to know the first command line argument is a string. Right? Remember that thing there? argv is an array, right? Right. The element type is the type in front. So the elements that are stored in the array are car star, right? Pointers to car. So it's an array of strings, right? The first string in the array is the second string in the array is the first command line argument, right? So argv1 is the first command line argument, right? The length of the string you can just obtain by just calling string length. 3, everybody gets correct. Shockingly, 4, 75% of the class gets wrong. So 3, you're given an array of car. What's the longest string you can store in that array? It's 9, right? Because you need the extra character for the null terminator, right? \0. Remember, the null terminator is \0, right? Right, \0. It is not /0, right? So that's wrong, right? About a third of the class writes that. So that's 9. And now the next question is not supposed to be hard, but it's never answered very well. So this one says, how do you store the string q in the array without using a function? Right? If you could use a function, you could just use string copy, right? Or sprintf, or something else. There's another way to do it. I don't remember what it is off the top of my head, right? So to write the string q into the array, right, you set the first element of the array to q, right, and then you set the second element of the array to the \0, and away you go, right? You see all sorts of funny answers for this. So you'll see like ARR equals q, the string q, right? Or you'll see ARR0 equals the string q, right, not the character q, right? Often people forget that you have to put the null terminator in, and you see other weird things as well. Right? There are no trick questions on the exam, so don't think I'm trying to trick you by asking something. Right? This is just trying to elicit basic knowledge from you. Okay, so this one has this question has a bunch of variations that I could ask. So this one says, what if anything is wrong with the following function declaration? Right? And so this looks like its method name is the function name is called 10. Right? It looks like it returns an array of int, and the comment says it returns an array containing the values 1 through 10. Right? And so this particular version of the question, the problem is that you're not allowed to return an array from a function. Right? You can't do it. If the question looked like the following, right? So what if anything is wrong with that function? Now the answer is nothing's wrong with that function, right? It returns an array of int, right? Or it turns a pointer to the first element of an array that's of length 10, containing the values 1 through 10. Nothing wrong with that, right? If I change the comment so that it returns an array containing some number of random values, right? Now there's a problem, right? The problem is that, sure, it can return an array of some number of random values, but whoever gets back that array has no idea how many elements are in that array, right? And they don't know how long that array is. They know it's at least 1, because there are no zero-length arrays in C, but that's it. That's all they know, right? So that's no good either, right? And so there's a bunch of variations on this type of question that could be asked. Right. But the one that was shown to you at the beginning was you can't return an array from a function. Next question just tests whether or not you can use a structure. Right. The thing to remember with the structure is that struct is part of the type name. Right. So the full type name for struct point2 is struct point2. Right. It's not just point2. So when you create your variable, you have to write struct point2. Right. Unless you have a type def, but in this case there's no type def given, so you need to write struct point2 here. Next question is exactly the same, except it asks you to allocate memory for a struct point2 object, and then use the pointer to set the values of the point. Right? So of course you call malloc. Right? I think the malloc, everything in black was given to you. So call malloc, get the size of the object that you want to allocate, right? And then because you have a pointer and you want to set x and y, the easiest way to do it is with the arrow operator. So the first one, you could also answer the first one by writing p dot x equals something and p dot y equals something after making p. Right? So this one's testing, can you use a plain old structure? This one's testing, can you use a pointer to a structure? Pointer to a function. So this one says you've got this function here, or this function declaration here, and it wants you to make a pointer to a function. It wants you to make a pointer to that function, basically, is how to write that, right? So remember, how do you make a pointer to a function? You take the function, so you take everything in gray, and you just write down everything in gray, right? So you write that down here, right? And then you replace the name of the function, right? List of, with a pair of round brackets, star, and then the name of your pointer, right? So replace, replace list of with round bracket star, and then this one says make a variable called p, so you replace it with p. Right? And then make it point to the list of function. So equals list of, equals ampersand list of is fine as well. This one's a binary number question, right? And so is the next one, right? So remember, we did talk a little bit about the binary operators. Typically, I don't ask you a long, involved question working with the binary operators. So usually, if I'm going to ask you a question involving the binary operators, they show up as a short answer question. So you have a 4-bit 2's complement binary number. So what is the most negative integer that you can represent? Right, so remember, in 2's complement, it's always only the first bit. The first bit is signed, right? Corresponds to -1 times 2 to the 4 in this. 0, 1, 2, 3 in this case, right? So the most negative number is the binary number where there's a 1 in the front. Everything else is 0. Right? None of those can be 1, because if they're 1, then you add in some positive value that's multiplied by 2 to the sum power. Right? So 1000 is the most negative 2's complement binary number that you can have. Next question is, you've got the binary number 1000, right? And now, how can you determine if x is negative using x, y, and a binary and a bitwise operator? So why is this number 10000, right? So that's your mask, right? You've got some 4-bit number x, right? So x, 3, 4, right? You want to know, is that first bit a 1, right? Because it's negative, right? So if you take the mask with 100, right? You get x and 1 in the first, for the first value here. All these others are 0, because x anything and 0 is 0. Right? So here you get x and 1 in the first bit. Right? So this says greater than 0. That should be not equals to, like that. All right. Right? So if this number here is a 1, right, then you know that that thing is negative. Right? A lot of students will just say if the first bit is a 1, it's negative. The problem is that you can't get the value of the first bit without shifting the bits over 3 positions. Right? There's no way to get the value of an individual bit in C. So you have to do something else. Right? So if that value is 0, then the number is just equal to 0. Right? If it's not 0, then the number is not equal to 0. And so the easiest way to do that is to compute the AND of the 2 numbers and then test if the result is not 0. All right, next question is a pointer question. So you've got 2 pointers pointing at elements in the same array, and you're asked about the pointers. Right? So if p is not equal to q is true, then what do you know about the values being pointed at? Right? So you don't know anything about the values being pointed at. Right? All that you have is p and q. Right? You're not dereferencing p and q to get the values pointed at. Right? So if p is not equal to q, all that you know is that p and q are pointing at different elements of the array, but you don't know anything about the elements themselves. Right? So you don't know anything. Right? If this was star p is not equal to star q, then you could say that the elements are not equal. Right? But if the pointers are not equal, you don't know anything about the elements being pointed at. Right? And of course, if you change that to, say, less than or greater than or something else, right? That all means, sorry. If p is less than q, you know that p points at an element that's whose index is smaller than q, than the element that q is pointing at. Right? If p is greater than q, you know that p is pointing at an element whose index is greater than the one that q is pointing at. Right? But in all these cases, you don't know anything about the element that's being pointed at. Right? You need to dereference the pointer to get the value. So we did talk about linked structures in the course. You should expect to see some sort of linked structure question. Right? So this one wants you to write a little loop that sets n, where n is a pointer to a node, so that it points at the second last node in the sequence. Right? So if you remember what the standard loop looks like for iterating over a linked sequence, right? It's while n is not null, right? And in that loop, n ends up pointing to the node after the last node. Right? So if n next is not null, then n stops. Then when the loop stops, n is pointing at the last element. Right? So if you want the second last node, it's just n next is not null, right? And away you go. There's other ways to write this loop as well, right? But that's the easiest. I think that's the most straightforward way to write that loop. Void pointers did show up in the course, right? You should probably expect to see questions involving a void pointer. Right? Can you dereference a void pointer? No, you can't dereference a void pointer. Why? Because when you dereference something, you get its value, right? The compiler doesn't know what's being pointed at, so there's no way to get the value of the object being pointed at. Right? If you need to dereference a void pointer, you have to cast the pointer to a pointer to the type that you think is being pointed at, and then you dereference that pointer. All right, so we implemented a generic stack in this course. Right? You could implement a generic list or a generic queue. Right? The technique is exactly the same. Right? This question is asking, if you did do one of those things, does it resemble a Java collection or a Python collection? Right? Represents a Python collection because when you use a void pointer to point at an element, you can store a pointer to whatever object you want. Right? So it represents a Python list. It's closest to a Python list, sorry. And then finally, the last question is asking you about hiding implementation details when you implement a data structure of some kind. Right? And so in C, you cannot restrict the visibility of something. Right? If someone can see a struct and they can see inside the struct, they have access to the members of the struct at all times. And so to mimic Java's private access modifier, we used what's called an opaque type. Right? So in the header file, we tell people that a structure exists, but we don't tell them what's in the structure. Right? In our implementation, so in our C source code file, that's where we put the definition of the structure. Right? And so you can see here my answer to every question, right, is very short. So don't spend a lot of time like writing out a full English answer. Right? I would prefer to read as little as possible. Right? So make your answers as short as possible so that they are understandable. All right, next question is basically using a structure. Right? So this one says you want to write a function that has two inputs, right? And so there are two strings as inputs, and they have unequal length. You want to return, your function should return a structure. Yeah, it can return a structure. It doesn't have to return a pointer to a structure. So it can return a structure where the structure has members, where one member points at the shorter string and the other member points at the longer string. Right. So make the structure and define the function for me. Right. So the structure is straightforward, right? One of the members is the shorter string, right? The other member is the longer string. Right? So that should be easy for you to define, right? And then write the function. So to get the length of the string, right, you could just use string length. Right? I remember marking this. This was weird. A lot of students didn't use string length. They wrote a loop to calculate the length of the string. Right? For the purposes of writing the exam, you're just wasting time. Right? Just use string length, unless the question says don't use string length, right? Right. So compare the length of s to the length of t, right? If the length of s is longer, then the longer string obviously is s, right? And the shorter string is t. Back here, I assume that the longer string is t, and the shorter string is s, right? And then just return the structure here. Right. Next question is also, you also get funny answers for. So this one wants you to compute the minimum and maximum value stored in an array of int. And it wants you to return the values back to the caller somehow. Right? The question says the values must be communicated to the caller somehow. Right? And it doesn't want you to use a structure, because the previous question just asked you to use a structure. Right? It doesn't want you to use an array, so don't dynamically allocate an array of length 2. Right? It's trying to force you to use a pointer. Right? That's the whole point of this question. Right? You can return one of the values. Does it say? Yeah, you can return either the min or the max with the return value. Here I chose not to, right? But you could. Right? The other value has to be returned by pointer. Right? So what are the inputs to your function? So number 1 is an array. So there's your array. Right? In C, remember C doesn't know the length of an array, so you also have to pass in the length. Right? So there's the length of the array. Right? I'm going to write the minimum maximum values to variables owned by the caller. So I need pointers, 2 int pointers, 1 for the min value, 1 for the max value. Right? And now it's just a matter of finding the min and max of the array and writing into min and max. Right? How do you write into min and max? Dereference the pointer. Right? That gives you the object being pointed at. Right? Assign the value to the pointed at object, and away you go. Right? Printing out a value is not communicating the value back to the caller. Right? Remember, the caller is another function, and another function can't read a printed value. Right? So printing out the value doesn't answer the question. Right? All this was trying to get you to do was to use a pointer to return the value. Okay, so the next question is typically a short programming question of some kind. Here I'm asking you to implement a string searching function, right? But it could be something else, right? So it doesn't have to be a string question. It could be an array question. It could be some sort of short file I/O question, right? Or something like that, right? So for example, the examples of implementing the little command line programs that we used in Bash, so the last 2 lectures, some of those would be appropriate to ask you here. Right? So for example, write a little C program that provides the functionality of the head program in Bash, right? Print the first n lines of a file. That would be a pretty reasonable question to ask you here. Here, though, I'm asking you for strrchr, that searches a string for the last occurrence of C in S. Right? So you just need to search that string S. I think this question says yes. So here it says without using any functions, right? And so that's stopping you from using string length, right? If you can use string length, then you can use indexing to solve the problem, right? So again, this one's trying to force you to use a pointer again. Okay, so how do you solve this problem? If you were in a language like Java, you would start from the end of the string, right? Unfortunately, you're in C, so you don't know where the end of the string is. So you might as well start from the front of the string, right? This one says strchr, strr, yes, strrchr returns the occurrence, a pointer to the last occurrence of the character in the string, right? So you just loop over the entire string looking for C, right? Every time you find C, just store a pointer to that value, right? And that's it. That'll give you the last occurrence, right? Right. So I'm going to return P, right? So P is a pointer to the found character. Right? So I'm going to start it as null, because you should return null if you don't find the character in the string. Right? And now you just want to loop over S. Right? So if you want to, you can use indexing in this question. I'm not going to. I'm just going to use pointer dereferencing pointers directly. Right? So while star S. Right? So remember, S is a pointer to character in a string. Right? Star S is the character in the string. Right? if star s is, so remember, star s is a character in the string, right? So that loop will run until it sees the null terminator, right? The value of the null terminator is 0. Right? If you find the character that you're looking for, right, just set p to equal s. Sorry. Right? Otherwise, keep going. Right? So to keep going, you want to go to the next character in s, right? Here you can just write s++, and away you go. If you type this into your compiler, it'll complain, it'll give you a warning. Right? It'll tell you that you're modifying s even though it's a const pointer. Right? It'll still run, but you will get a warning. Right? But this is fine for the purposes of the exam. Right? So that loop there looks at every character in the string. Right? When it finds the character c, it sets p to point to the character. Right? When you're done, p is either null, right, meaning you didn't find the character, or it's pointing at the last occurrence of c in the string. So now you just return p. Right? Yeah, so that's it for that particular question. That was actually worth 10. So that was actually worth a lot, given that you didn't have to write very much code. Right? If you're not so good with pointers, it becomes a little more complicated. Right? You have to create a little integer counter. You're going to use array indexing to access the string. Right? But it's not that much harder. Right? Eventually, you'll get down to here, and so you'll want to write something like return s plus I, where I is your counter. Okay, fourth question is the one related to some of the data structures we looked at. Right? So this one asks you about a linked stack. You could be asked about something else. Right? We also implemented a string, so it's worth looking at the QString implementation again. Right? I might ask you a question about that instead. This one wants you to write equals for two stacks. Right? So this is our stack structure here. It wants you to write a function that returns true if the two stacks are equal. It returns false if the two stacks are not equal. Right? The complication here is that you have a generic stack. Right? And so two stacks are equal if they have the same number of elements in the same order, and the elements are all equal. Right? You don't know, the stack doesn't know what the elements are that are being pointed at. Right? The caller knows what the elements are that are being pointed at. Right? And so here's a situation where you're going to write this function, and you need to write, you need to tell the function, how do you compare two elements for equality? Right? So remember, how do you do that in C? Well, you provide a pointer to a function that can tell if two objects are equal. Right? So here's my point. Here is my. Right. So right there. Right, is your pointer to a function that can determine if two values x and y, right, where x and y are pointers to the two elements, if they're equal. Right? This is actually a type def, right? And so I can use the name EQ as the name of a pointer to a function that can determine if the two elements are equal. Right? This question doesn't actually spell out that you need this, right? You have to infer this from the question, right? So provide a C function and any other required code that tests if the two input stacks are equal, right? So that and any other required code is where you have to infer that you need this extra function here. You need at least the pointer to the function here, right? I don't actually ask you to run the code, so you don't need an implementation of EQ. I don't think I do anyway. No, I don't. Right? Okay, so how do you write EQ? Well, you're just going to iterate over the nodes of the two stacks. Right? First thing you should do, though, is check whether or not the stacks have different sizes. Right? If their sizes are different, they can't be equal. Right? If they are equal, now you have to iterate. Right? So NS and NT, those are just pointers to the top element of the stacks S and T. Right? You know that the stacks have equal size, so you can look at just at one of the pointers. Right? So while NS is not null, right, that will loop over the elements or over the nodes of both stacks. Right? So while it's not null, at the end you're going to advance NS and NT. Right? When you look at each node, you're going to ask, well, are the elements in the nodes equal? Right? So you're just going to use that function there to tell if they're equal. Right? So if the element in NS, right, is not equal to the element in NT, right, you can return false because you know that the stacks can't be equal, right? Otherwise, you just go and look at the next node, right? If you look at all the nodes and all the elements in the nodes are equal, now you can return true, and away you go. Right? So this one is really just a pointer to a function question, and it's also can you iterate over a linked sequence question. If you get a QString function, it's basically asking you, can you work with a dynamically allocated array question, right? Because that's all a QString is. Last question is so you haven't seen file I/O yet, so guess what? The last question is a file I/O question on this exam. Right? So this question here asks you to do a few things. It wants you to open and read a file that contains a bunch of numbers in it, right? And the numbers are integer followed by a comma, followed by an integer, followed by a comma, followed by an integer, and the file can be multiple lines long. Right? The end of a line does not end with a comma, right? So it's just a new line character sitting here. So it wants you to read in a file that looks something like that, right? And it wants you to store those values in an array, and then it wants you to do something else with those values. But we'll get to that in a second. So it wants you to write a program. The first command line argument is the name of the file to read. Right? So you want to run your program like that. Right? And then you want to read in a file that looks something like that. There's always a hint in these questions. Right? So there's a hint right here. Right? So when reading in the file, it says use a loop that attempts to read in one integer followed by one character. Right? If you remember how to use fscanf, that's dead easy to do. Right? If you don't remember how to use fscanf, that's a little harder to do. So it might be worth looking at fscanf, right? But the hint is useful, right? So if you look at the hint and then you look at the example, it says try to read in an integer followed by a character, right? And so if you look here, it says, oh yeah, that makes sense, right? I have a 5 and then a comma, right? And then I read in another integer, so minus 100 and a comma, right? And then you see, well, then I read in an integer, and then you say, well, hey, there's no character, right, after the 3, and you would be wrong, right? There's a new line character sitting right here, right? At the end of the file, right, there's an integer, and then remember in Linux, there's a new line character at the end of the last line as well, right? So reading in a integer followed by a character is guaranteed to work for this particular file. Right? If there were spaces allowed in the file, it complicates things, right? But I generally don't try to complicate your life on the exam. So read the hint and try to understand what the hint is hinting at. Right? You don't have to do any error checking except to test whether or not the file is opened correctly. Right? It says here there's no predefined upper limit on the length of a line in a file. Right? And so this is trying to stop you from just allocating a giant array and then reading stuff into the array. Right? And it also says there's no predefined upper limit on the number of values in the file. So again, it's trying to stop you from just allocating some enormous array and reading stuff into an array. Right? It wants you to dynamically allocate the array to store the values in. Right? So you want to read in the values. You don't know how many values there are to read in. Right? So the easy strategy for this type of problem is to read the file twice. Right? Read the file the first time to figure out how many numbers are in the file. Right? Dynamically allocate the array. Rewind the file, and then read in the numbers and store them in the array. Right? If you want to be fancy, right, you can reallocate the array as you read in values. Right? But it's, for the purpose of the exam, it's easier to read the file twice. So there's our main function. Right? It wants you to test if the user passed in the right number of command line arguments. Right? There's one command line argument. Right? So you're going to test if argc is not 2. Right? Set the exit status to 1, so return 1 works. Right? Open the file to read, so you need to use fopen. Right? You're going to open the file for reading. Right? You're going to test, is the pointer returned by fopen null? Right? If it is, you're going to exit with 1. Right? And now just read in the file the first time. Right? So that loop there reads in the numbers in the file using the hint. Right? n is going to be the total number of integers in the file. Right? So I can just use a little infinite loop. Right? I'm going to try to read in a value one at a time. So I'm going to use fscanf to read in one int. Right? If that works, great. I know there's an int, so n goes up by 1. Right? The hint says read a character, so I'm just going to use fgetc to read in the character. Right? And keep on going. If fscanf fails, right, so eventually you're going to read in the last integer and the last new line in the character. Right? The next time the loop runs, fscanf will return 0. Right? And I don't remember if I told you what it returns here. Fscanf, I didn't tell you what it returns. So you do need to know what it returns, right? It returns the number of successful conversions. Right? So if it can't successfully convert something, you end up in the break statement, right? And now the loop stops. Right? Rewind the file, right? And now read in the n values into an array. I don't even need to dynamically allocate an array here, right? Because this is a main function. So I can just use an array with with a fixed lifetime. Right? It doesn't have to be dynamically allocated in this case. Right? And now just read in the array. Read the values into the array. Right? So just use fscanf again. Right? This time read direct. So I'm reading directly into the array here. Right? If you don't like this, if you don't like reading directly into the array, just make a variable, read into the variable, and then store the variable in the array. Right? It doesn't matter. Right? Read in the character that follows the integer, right? And away you go. Right? You even know how many elements to read, so you can just write a little for loop that runs n times. Right? The second part of the question says, call a function that returns a new array containing all the non-negative values in the array that you just read in. So my function is non-neg. Right? It's going to do n is the number of elements in that array, right? Now, somehow you need to communicate back to the caller how long is this array that's being returned, right? Way back in question 2, I used a pointer to something, right? Here I'm not using a pointer to something. I'm just returning the array back here. Right? And so what I'm going to do here is I'm going to use a special value in the returned array to indicate the end of the array. Right? If you want to, just put in a third parameter here that's a pointer to some int, right, where the function can write the size of the returned array into. Right? So I'm going to return this returns a new array containing all the non-negative elements in here. Right? So I'm going to allocate a new array. Right? I have to allocate an array here. Right? I have to use dynamic memory allocation here if I'm returning an array. Right? Otherwise, the array doesn't exist after I return from the function. So that has to be dynamically allocated. Right? I can make it n long. I don't think the question says to trim it down to size later on. So you don't have to worry about making it exactly the right size. Right? If you have to worry about making it exactly the right size, this complicates your life a little bit. And now I'm just going to copy all the non-negative elements from ARR into NN. Right? So loop over the n elements in ARR. Right? Whenever you find a non-negative value, just copy it into NN. Right? Finally, if j is less than n, right, you're going to write in the j is less than n. If j is less than n, right, I'm going to write in a -1 to indicate the end of the array, right? If all of the elements in the array are of length, are non-negative, right, then the caller can reasonably expect that all of the elements in the returned array, which will be of length n, are also non-negative, right? And so I'm going to use a -1 to indicate that this is the end of the array. Otherwise, right? And that's it. And so now print out the non-negative elements. Right? And so NN, right, remember has a, I guess this is technically wrong. While value, this wants you to sum the elements in the array. There's a bug in my answer. While value is greater than or equal to 0, I need another counter here, technically. But never mind, it's fine. Right? Just sum the elements in the returned array. right? Print out the sum. And the question says clean up after yourself, right? So we dynamically allocated that array NN, so we have to free it, right? I opened up a file at the beginning of the function, so I have to close it, right? Return statement here is optional, but I guess we're done, so I'm going to return 0 there. Right? And so that's the 2023 fall exam. Right? If you look on OnQ, there are 2 other newish exams, and then there's a whole bunch of old exams. The old exams weren't written by me, so they were written by other people. And they are all wildly varying in style and types of questions asked. Right? They are there. The answers are also there. The old exams also have bash questions in them. So if you see any bash, just ignore it. They also covered, occasionally a different instructor will cover different topics. So if there's anything there that doesn't look like something we did in the course, you can just ignore it. Right? Yeah, and so there's an example of an exam. Any questions about the exam or about any of the questions I just covered, or anything that you might expect to see on the exam, or anything else? Anything? Any other questions for me while I'm here? Yes?
We have 3 hours to be.
Oh, yeah, 3 hours. Yeah. Yep. I mean, it's just C, right? So whatever the basic language you should know, you passed 124 because you're here, right? And then there's really only how to use a C array, right? Pointers to functions, dynamic memory management, right? So malloc, realloc, and free, right? And file I/O, right? So there's really only 5 other things you have to pay attention to. Anything else? All right, that's it for the course. For all other updates, I guess just look on OnQ for the announcements. Right, there will be extra office hours closer to the exam. Right, Monday next week there's office hours as well, but I expect 124 is going to be using those. Right, because the 124 exam is next Tuesday. All right. Okay. Thanks, everybody.